Good morning, boys and girls. This Tuesday, March 24th. We're going to finish a couple things with domain and range today. Just more cumulative review of how it looks, different forms, how to explain it. And I'm going to have two assignments on Classroom. The first one being a review of this, and I'll provide the answers in just a minute. I'll upload them to the Classroom doc. And then I'm going to teach you something about composite functions, and then this will take us through probably the rest of the week because it'll take a little while to understand it and really sharpen our skills. So first things first, I got this graph right here, and I got these like oval shaped things because the work today is asking you to do that. So pretty much just think of this as your X, think of this as your Y, and what is it? Just identify ordered pairs. Okay, so I got this as -3, and this is also -3. Okay, I got this as -2, -1. I got this as 0, -1. I got this as 1 and 0, and then I got it at 1 and 3. Sorry, just waking up. Well, it's not necessary for me to write 1 twice because it's already written there, but it is necessary for me to write -1 twice over here. You'll see why. Now, I can identify this is not a function by one of two ways. I can simply just connect the dots, right? And I can see that this graph will not pass the vertical line test because my vertical line right here hits 2 points in the same spots. Or another way to look at it is, I got this goes to this, this goes to this, this goes to this, 1 goes to 0 and to 3. And we just worked over the past couple of days about one input can only have one output in order for it to be an actual function. However, it's possible to have two different inputs have the exact same output. That is allowed. So, is this a function? No. And you'll get plenty of practice with this today in one of the worksheets that I put up on Classroom. Now, another type of question you might see is something like this, where it's a graph and it wants to know the domain and range. So we'll answer this question if it's a function at the very end. But real quick, my domain, remember open circle means it's not included. So our X, remember our domain is always referencing our X, our range is always referencing our Y. Or another way to think about it is, this is my input, this is my output, okay? Remember, this is the answer. So domain, I can see that it's less than -4, and it goes all the way to equaling +3. That's where this graph exists. So you can explain this one of two ways. You can say X is less than -4 and X is, sorry, my apologies. X is greater than -4, I made a mistake there. X is greater than -4 and X is also less than or equal to 3. Or we can do this from now on if you want to get in the habit of notation correctly. I got -4, X is greater than, but also less than or equal to 3. So I'll accept either way of expressing the domain of this function for now because you're just learning this. I'm not too worried about you getting the hang of this just yet, but at least do this, at the very least. So that explains all my X possibilities, and I can see my range, the up and down. I can see that this graph exists between +2 and -3. So Y is greater than or equal to -3. I know it's or equal to because I can see my graph hits right there at -3, and it also hits up here at +2. It touches those spots. And Y is less than or equal to 2. Or you can just say this. -3, Y is greater than or equal to -3, but also less than or equal to 2. Either format will suffice for this. And is this a function? Take your vertical line, whatever it may be, and I can see my graph only hits my vertical line once every time I move it along here. So this does pass the test, and yes, this is a function. So this is more of a review worksheet from what we did the past couple of days to clear up any last minute questions you guys might have regarding anything that looks or resembles stuff like this with domain and range. It is the fundamentals to move forward and understand this, so make sure you guys master this. This is the first worksheet. Now, the next worksheet is a worksheet on composite functions. So, this is brand new for you guys, so we're going to take our time in learning this. So, we got composite functions. So we're going to use these functions for now, and we'll make sense of it in just a minute. 4x minus 2, and I got g of x equals negative 2x, and I got h of x equals 2x squared minus 2. I got 3 different functions to work with throughout this entire process. So, first things first. Here's what a composite function looks like. F of g of 5. Okay? Now, we'll get to this in a second, but let's go back. Let's pretend, remember we did this earlier? I asked you guys, what is f of 2? Well, this was the input for the f function, so I input this in place of x, and this is now 8 minus 2, so this answer would be 6, and I'd be done, okay? We're doing the exact same thing, but now it's just embedding more functions with it. So now what's going to happen is I work from the inside out. So I do the same thing I did before, but now I start with putting the 5 in place of the x in the g of x function, okay? And then whatever answer I get from this is now the input for the f of x function. So watch. I'm going to input 5 for this function, okay? And whatever answer I get from that is now the input for the f of x function. So now negative 2 times 5 is negative 10. So that's now the input for the f of x function. And this is how I want you guys to write your work so that you organize yourself and you can, again, show thinking and not rush through this stuff. This was the negative 10 was the answer from this. Now this is the input for the f of x function. So I can go ahead and do my work. I input negative 10 for x. So I get 4 times negative 10 minus 2, negative 40 minus 2 is negative 42. And that's all you do, okay? So let's keep doing this with a couple more. And again, I'm just using these functions for now. All right, now the new question is going to be, what is g of f of negative 2? So I go into the f of x function now, because that's the inside one, input that negative 2, and I want some of this to be mental math. I don't want you guys to do all this writing if you don't have to. So negative 2 in place of x is negative 8, minus 2 is now negative 10. So I got g of negative 10. I input the negative 10 in place of x, negative 2 times negative 10 is 20. That is good enough for this type of work, okay? Now let's do some more examples. There's those. I'll leave this one up. I'll do one more. Now I'm going to erase it. Hit pause if you need to copy some stuff down real quick. F of g of x. Now it's going to get a little harder, okay? But again, the thinking doesn't change. If x was a number, we would put this in place of this, right? And I would get an answer, and then that answer would then be the input for the f of x function. Now, I don't have a number, so now what this is saying is take the entire g of x function and put it in place of x here, just like we would if it was a number. So now, this entire expression, negative 2x, is now the input in place of x right here. So now this says f of x equals 4 times, because that's, remember, it's being multiplied against the x, this entire function. negative 2x minus 2, okay? Now, just to solve this out, we just multiply negative 8x minus 2, and I cannot combine like terms, so this is your final answer. Good as that, okay? Now let's flip it around. Now let's say I just said, instead, g of f of x, okay? Again, I'm now replacing this entire expression in place of just the x on this expression to figure out what's going on. So now it's my g of x function is equal to, the input is this, but I do negative 2 times, because I got to replace x with this entire expression, 4x minus 2. Carry out the distributive property, and I get negative 8x plus 4. That is it for something like that. And now, I'm going to take us to a couple more examples, and then we should be good to go on this for the beginning part of today's lesson. So, I don't know why they do this, to be honest with you, but I want you guys to be comfortable with different ways of reading the same exact concepts. What if they asked you to find h of f of x? Okay? This little dot right there, that open circle, means literally the exact same thing as h of f of x. There's no difference right now for what we're doing. So I want you to not be alarmed when you see this format, okay? Because it means the exact same thing as this format. Now, how do I do this when I'm squaring some stuff? And this is where I want you guys to pay close attention. Again, just like we just did a second ago, I now input this entire expression in place of x over here. Okay, now watch this. So now this is literally h of x equals, I do 2 times 4x minus 2 squared, because I have to square whatever I put in place of x over here. So that's what I'm doing. This expression is squared. And then I have to still subtract 2 at the end. Okay? Now, squaring an expression like this doesn't mean distribute the squared to this and to this. Because I'm squaring an expression, this is how you square an expression. But what I mean by expression is this has an operation going on inside of here. If this was just 4x to the power of 2, I would distribute the power 2 to the 4 and to the x. But now I have an expression, so I have to multiply the entire parentheses by itself. So this really means 4x minus 2 times 4x minus 2, and this is why we got to carry out FOIL correctly. Remember FOIL, first, outer, inner, last. So I do 4x times 4x, which is 16x squared, 4x times negative 2, which is negative 8x. Again, negative 8x, and last but not least, positive 4. So now this entire expression, when I combine my two like terms, is now going to be 2 times 16x squared minus 16x plus 4 minus 2. Last but not least, because this coefficient is 2 in front of this x squared over here, I got to make sure I multiply everything on the inside by 2. So now this is 32x squared minus 32x plus 8 minus 2. And last but not least, combine your like terms. 32x squared minus 32x plus 6. We are done for something like that. Now I'm going to do another one just to show you another way to go through this type of stuff. So there's that. Hit pause if you need to copy some stuff down, but let's get going. Now let's say I had this instead. Let's say I did h of x. And now again, if this was just a number, I would put this in place of x, and I would do the math and then take that answer and put it in place of x in the f of x function, and then do that. But it's not always that easy. So again, we know if you want to do this for yourself so you don't get confused, you know this means the same as f of h of x. Okay? So put this in place of the x right here. So now we're doing the f of x expression will equal 4 times, put this entire expression in place of x. So now this is 2x squared minus 2 minus 2. Okay? Because I still got to represent this minus 2 as part of this equation because that's in that expression. So now this is f of x equals 8x squared minus 8 minus 2. And your final answer is 8x squared minus 10. And we are done. So that takes me to that. And then my last example for you guys is going to be something different, which is the last couple questions of the second worksheet that I posted today. And I'm going to do examples like it. It's just the directions might be a little confusing, but I want to just do some examples that will help you get through it and not let the directions confuse you any more than you might already be. So let's say, and this is what I'm saying, because it's going to just have brackets and you haven't seen this yet, but it doesn't change what we do. So f of x equals, and again, I don't know why they do this, but it is what it is. And then I got g of x equals negative 5x. And then I got h of x equals 12 over x. All right, so let's do this. Let's see f of g of 20. Okay? So don't let these brackets confuse you. Anything here, follow the rules. Remember, this is the same as f of g of 20. Okay, put this in place over here. Negative 5 times 20 is negative 100. So now I'm working with the input of negative 100 in place of this expression. I just put this in place of x, and I get my final answer of negative 200. Easy peasy. F of h of x. All right, again, be my guest. F of h of x, put the entire h of x function in place of x here, and do your work. F of x equals 2 times 12 over x. Remember, numerator times numerator, your final answer is f of x equals 24 over x. And that is your final answer. And the last one is just h of f of 3, for instance. Okay? H of f of 3. You don't have to do this if you don't want to, but having done this for a long time, some kids like to use the same format so they don't get confused. Input the 3 for the x and the f of x function. So now this is going to be h of 6. Input the 6 in the right here on the x right here. So 12 divided by 6 is 2. And we are done. The instructions will be on Classroom. They will tell you guys exactly what to do. I will be available again today from 12:30 until 1:30, but I'll get there in the class early, probably like around 12:10. So I'll see you guys then. Have a good one.